start by setting the financial reality. Today, $30,000 is the absolute floor for buying a modern, reliable crossover SUV, but hitting that price point comes with a harsh reality. You cannot buy a vehicle in this bracket that is good at everything. Automaker profit margins are incredibly tight under $30,000. If they give you a premium feature in the cabin, they have to rip the budget out of the suspension to pay for it. That creates the central trade-off of this entire class. You either get interior space and a bulletproof engine, or you get a refined, comfortable ride. You don't get both. This brings us to the major contenders clustering right up against that price ceiling: the Toyota Corolla Cross, Honda HR-V, Mazda CX-30, Subaru Crosstrek, and Hyundai Kona. If you try to compare these cars by lining up their spec sheets, you will make the wrong choice. Horsepower numbers and cargo volumes completely ignore the subjective daily agony of a loud cabin or a terrible ride. Instead, we evaluate these using a scenario match. We group the vehicles by your actual lifestyle and use case, rather than relying on raw data points. The goal here isn't to find the mathematically perfect car, it's to actively choose the compromise that solves your specific daily friction points. We start with the default choices of the segment: the Toyota Corolla Cross and the Honda HR-V. These are for the buyer whose primary concern is 10-year powertrain reliability. The secondary motivation here is holding on to maximum resale value for a future trade-in. The math works out in your favor. Both of these vehicles will breeze past the 150,000-mile mark, requiring little more than basic oil changes and tire rotations. This chart tracks our core metrics. You can see they deliver massive physical space, with the HR-V offering over 55 cubic feet of cargo volume. But look at the third bar. The severe trade-off for space and reliability is NVH, noise, vibration, and harshness. Both of these cars let a massive amount of wind and tire noise into the cabin, making long highway commutes exhausting. Add in a suspension that wallows through corners and engines that struggle to get up to speed, the HR-V puts out a meager 158 horsepower, and the daily drive becomes a chore. These legacy vehicles are strictly bulletproof appliances. They are perfect for hauling a family, but they offer absolutely zero joy to the person behind the wheel. If you refuse to tolerate a loud, plastic-heavy daily commute, your alternative is the Mazda CX-30. To maximize your budget, you want to target the 2.5S Preferred or Select Sport trims, which sit right between $27,000 and $29,000. Inside, Mazda delivers near-luxury refinement. The material quality punches way above this price class, trading hard plastics for soft-touch surfaces. They also solved the NVH problem by using dual-pane glass to keep the cabin quiet, and a traditional automatic transmission that eliminates the loud droning you get from a CVT. It also delivers a dynamic advantage. You get 186 horsepower and a handling feel that is vastly sharper than anything from Honda or Toyota. This graphic shows the exact cost of that refinement. When overlaid against the HR-V, you can see the CX-30 has a punishingly tight backseat and a severely limited 20.2 cubic feet of cargo space. The CX-30 is a brilliant budget luxury vehicle for solo drivers or couples, but as a family hauler, it falls completely flat. Some buyers view cars as physical tools rather than luxury lounges. For that group, we look at the Subaru Crosstrek in its base or premium trims. The Crosstrek delivers serious physical capability out of the box, with a massive 8.7 inches of ground clearance and standard symmetrical all-wheel drive. Looking at this radar chart, you can see where Subaru spent their money. The highly compliant suspension is designed specifically to absorb the impact of terrible, broken roads. The drawback is what happens on the inside. You get a purely utilitarian, plasticky interior, a sluggish transmission response, and an outdated infotainment system. If you care more about modern aesthetics and digital interfaces than dirt road capability, you flip over to the Hyundai Kona in the SEL trim or the VW Taos. These models prioritize class-leading tech features, giving you massive 12.3-inch digital clusters and standard wireless charging for the same $30,000. They also deliver aggressive exterior styling that refuses to blend in with the legacy traffic. This value graph reveals the financial catch. You are going to deal with a much steeper long-term depreciation curve compared to the Japanese legacy brands. You are also taking on slightly less proven 10-year powertrain reliability than you'd get from Toyota. Choosing these alternatives requires abandoning the middle ground. You must decide to go all in on physical dirt road capability or all in on stream tech. The core rule of the $30,000 market is this: do not buy a brand badge. Buy the specific vehicle that solves your daily friction points. This flowchart maps out the decision. Start with your most restrictive physical limitation. Do you frequently carry adult passengers in the back seat? If the answer is no, and you value a quiet, premium cabin over utility, the map points directly to the Mazda CX-30. If the answer is yes, you need space. If you also deal with harsh winters or dirt roads on a weekly basis, the path flows over to the Subaru Crosstrek. But if you don't face extreme weather, view the car strictly as a family appliance, and want the safest financial bet for the next decade, your answers are the Honda HR-V or Toyota Corolla Cross. Acknowledging your actual lifestyle, rather than what looks good on a spec sheet, is the only way to avoid buyer's remorse when spending $30,000. Average car prices are pushing buyers to their financial limits, meaning a new vehicle is a heavy, long-term commitment. Consumers are desperately hunting for cars guaranteed to survive 10 years or more without bankrupting them in repairs. For a century, the golden rule of automotive engineering was absolute. Keep it simple. The fewer moving parts a machine has, the less there is to break. Look at the powertrain of a modern hybrid. Under the hood, you have a combustion engine packed alongside 3 separate electric motors, a high-voltage inverter, and a massive lithium-ion battery pack. It is a direct violation of the simplicity rule. Yet, if you look at buyer trends for vehicles like the 2026 Toyota Corolla Cross, a strange anomaly emerges. Consumers and automotive firms are actively bypassing the simpler gas model, deliberately choosing the highly complex hybrid version, specifically for its long-term reliability. It defies basic mechanical logic. We have to figure out how packing a vehicle with massive electrical and physical complexity somehow results in fewer breakdowns. The answer starts underneath the vehicle, inside the transmission. Most standard gas-powered compact SUVs rely on a continuously variable transmission, or CVT, to transfer engine power to the wheels. This standard CVT uses a heavy-duty metal belt sliding rapidly back and forth over steel cones to change gears. That constant metal-on-metal contact creates immense friction and heat, turning the transmission into a wear item that eventually degrades and fails. Toyota's hybrid architecture, known as an eCVT, engineers out the failure point by replacing the friction-heavy belt and cones with an interlocking planetary gear set connected to electric motors. Rather than relying on physical parts sliding under high tension, the eCVT uses magnetic force and electric current to manage the gear ratios. It bypasses the metal-on-metal grinding completely. By eliminating these physical contact points, the hybrid system removes the most vulnerable, friction-heavy weak link of the traditional internal combustion powertrain. Expanding our view to the entire fifth-generation hybrid system, the Corolla Cross pairs a 2.0-liter four-cylinder gas engine with a highly orchestrated 3-motor setup. These electric motors are explicitly programmed to take the brunt of the vehicle's hardest physical labor. When accelerating from a dead stop, the moment of highest mechanical stress, the electromagnetic coils instantly engage, launching the car with zero initial effort from the gas engine. This continuous load sharing means the internal combustion engine runs at lower RPMs and handles a fraction of the actual mechanical abuse. Over a 10-year lifespan, the gas engine simply experiences thousands of hours less wear and tear. No mass-produced machine is immune to reality, though. A recent recall affecting over 55,000 vehicles, including the 2026 Corolla Cross Hybrid, required a mandatory fix for the system's power inverter. The root cause of the recall was a single bolt inside the inverter terminal that was not tightened properly on the assembly line, ultimately creating a severe electrical short risk. This is a critical distinction. It was a factory assembly error, rather than a flaw in the mechanical design itself. While human mistakes on the assembly line happen, the underlying hybrid architecture operates exactly as intended, constantly absorbing physical punishment to extend the vehicle's overall lifespan. We can verify the effectiveness of this mechanical design without ever opening the hood. We just have to look at corporate finance, where the vehicle's manufacturer warranty, translates engineering confidence into legally binding financial liability. This chart shows exactly how much risk the automaker is willing to absorb. This standard gas powertrain warranty cuts off at 5 years or 60,000 miles, but the hybrid system is covered for 8 years or 100,000 miles, and the hybrid battery guarantee extends all the way to 10 years or 150,000 miles. Global automakers do not write 150,000-mile guarantees based on marketing optimism. These warranties are calculated using massive sets of actuarial data, proving that replacing these components out of pocket is a statistical rarity. That actuarial data is the result of decades of iterative engineering. By constantly refining the architecture introduced by early models like the first-generation Prius, Toyota managed to scale an experimental concept into their most robust, trusted platform. The modern hybrid effectively flipped the logic of mechanical engineering. By integrating advanced electrical architecture to bypass physical friction, they proved that carefully added complexity actually subtracts long-term wear.